Okay, so this table is set up a little bit differently than before, but it's still the same idea where there's like overlapping categories and two different totals. So up here we have the hair color of the child, so this means these are blonde children, blonde child, and a brunette child. And then over here we have the hair color for the mothers. These are blonde moms and brunette moms. Okay, and then on the columns, total blonde children, total brunette children. And there's 54 total people. This is 54 for both, so there's 54 moms and 54 children. So for all of these, it's like 54 pairs. One pair is a mom and a kid. So how likely is just the same as asking what's the probability. So how likely is it that a child has blonde hair? So we don't know anything about the mom's hair color. We don't care about the mom's hair color. We just want our child to have blonde hair. So you go all the way down to the total. There are 28 total blonde children. And since we didn't know anything for sure, we would use 54 as our total. So it should be 28 over 54 for number 1. Okay, the only time you're going to take a number from the middle is if you know something about both, the mom and the kid. If we're only talking about one, you're going to use one of the totals at the bottom or on the side. Okay, so number 2, how likely is it that the mother has brunette hair? So we only care about the mom's hair color. We don't know anything about the child's hair color. So we go brunette moms all the way across to the total. So 29 brunette moms over the total number of moms, 54. So 29 over 54 for number 2. Any questions on those two? Those are just knowing which row and which column to look at. Okay, number 3. This one's a little different. How likely is it that a mother and child will have the same hair color? So the same hair color in this case would be either they're both blonde or both brunette. Both of these situations would fall under the mom and child having the same hair color. So now that we're talking about both, we have a hair color for the child and a hair color for the mom. This is where we're going to be getting our numbers from the middle part here because we have two things to look at. So for a blonde mom and a blonde child, where it overlaps is at 15. So there are 15 pairs of mom and children that both have blonde hair. So do 15 over 54 for the both blonde, or we're going to add, now we need them both to be brunette. So brunette moms and brunette children, where they overlap, is at 16. So there's 16 that are both brunette. Then you would add those together, so 31 over 54. Okay. Any questions on that one? Okay. So again, just because there was the word and here, where it said mother and child, that doesn't mean multiplication. You got to look at what we're actually asking, and it's about them having the same hair color. Okay, number 4, how likely is it that a mother and child will have a different hair color? So this would be either having a blonde mom, and spelled mom with an E, blonde mom and brunette child, or brunette mom and blonde child. Right, those would be them having different hair colors. Now remember with these two-way frequency tables, and we have this and here, if you can find the intersection point of the and categories on the table, then you don't have to do any multiplication. So we want blonde mom, brunette child. They intersect right there at 10. That is the number that goes in your fraction. If the two things we were looking for, the two and events, weren't on opposite sides or weren't on the same table, then that's when you would still do the multiplication that we usually do for and probability. But if you have the table and you can see where they intersect, just use that. So blonde mom, brunette child, there's 10. So it'd be 10 over 54 because we still don't know anything for sure. And then or. And then a brunette mom or a blonde child. So brunette mom, blonde child is 13. So plus 13 over 54. Which should give us 23 over 54. Okay. Good on those two. Okay. So now the last one. Now suppose we know that the mother has blonde hair. Using this given information, or use this given information to answer the questions. So now we are given some information. Our mom has blonde hair. She does not have brunette hair, which means I don't care about the brunette mom row anymore. I only care about the blonde mom row. I don't even care about these totals because I'm eliminating part of it. I know she has mom has blonde hair. That's the only stuff I'm going to be looking at for the rest of the questions. So how likely is it that the child will have brunette hair? Just looking at our row that we're focused on, child having brunette hair is 10 out of the total, which is 25. Because remember, with conditional probability, when we have given information, our denominator is going to get smaller. Our denominator is going to change. Okay, and then our last one, how likely is it that the mother and child will have the same hair color? Well, we know that mom is blonde, right? We know that for sure. So we want the child to also have blonde hair. So mom blonde, child blonde. And that is 15 over the blonde mom total. 25. Okay. Questions on that warm-up? All right.